Okay, so today let's consider deriving the equation for maximum torque transmitted by a solid circular shaft. For that, we'll consider a circular shaft, a solid circular shaft subjected to torque T. Okay, this is a solid circular shaft. Now here we will consider a maximum shear stress tau. We'll have r as our radius for the circle. This will be r. Okay. We'll also have q. Q will be the shear stress at r, distance r from center. Okay, now this is r, so q will be acting over here, right? Now let me consider an elementary ring of thickness. Let's say the thickness is dr. This is the ring and the thickness is dr. So if I suppose that I want to find the area for this elementary ring, since it's infinitesimally small, I'll say that the area will also be small. So the dA, that is the area of this ring, will basically be the circumference into the thickness. So the circumference for a circle is 2 pi r and the thickness is dr. So we get this, right? Now we know the torsion equation. I'll just write it down over here. That is tau by r, q by r, torsion equation. Okay. From this we find our q, which is the shear stress acting at r. Okay, so this is q. Now after doing all this, we'll find the turning force. Now the force will be shear stress into area, shear stress into area, q into dA, r tau by r into 2 pi r dr, which is 2 pi r square dr. Here we had this and we also had a tau. Okay, now since we want to find the torque is nothing but turning moment, right? So turning moment, now this moment is caused due to the force, right? Due to turning force. This will be for basically what's the formula for moment? It's force into distance, right? So this is our force, 2 tau pi r square by capital R dr. And what is the distance? Distance is this small r, right, from the center into r. So if I solve this further, I'll simply get r cube capital R, right? So we know that this moment that we found is just the moment of this small part. So to find the total torque, I'll have to integrate this. So I'll get the torque about the whole shaft. So I'll say that on integrating, from where we'll do it from 0 to r, right? From 0 to r, we'll get 0 to r. Just write the thing as is here, right? Basic integration, let's just pull out all the constants outside. We are left with r cube dr, which will be right? And this will be r0, right? Now I'll further solve it up. I'll write 2 tau pi by r. This will be becoming capital R minus 0, so it will basically be r4 minus 0. I'm just skipping that part. And we also have a 4 here, let's not forget that, right? So this will get cancelled, this will become cube. 1 and 2 and 4 will get cancelled. We are left with r cube, right, by 2. Okay, so now also this 4 was outside just before the cube thing, alright? It's not included inside it. So, and now we are writing r by 2. Sorry, my bad. We are supposed to write here d by 2 because r is d by 2, right? So now what I'll do is just write it further. 2 pi d cube by 2 ka power 8 is 2 ka power 3 is 8, plus we have a 2 over here, that will become 16, which is our required answer.